632 meters tall, 128 floors, over 100,000 tons of steel and glass stand piercing the Shanghai skyline. But what if I told you that the ground beneath this entire structure has already swallowed itself by 3 meters? Imagine this. You are standing on the observation deck, 562 meters above the city, when the floor beneath your feet shifts by just a few centimeters. That's all it takes. A few centimeters repeated every single year for 100 years straight. The foundation doesn't crack instantly. It doesn't need to. Engineers tracking the surrounding district have recorded cracks splitting open in the roads. Just steps from the tower's base, 24 million people live in this city. The financial heart of China sits directly on top of ground that has been measurably, continuously sinking since before any of their grandparents were born. What makes this truly alarming is that Shanghai Tower isn't built on rock. It's built on soft river mud, the kind that compresses the moment you press down on it. So, is the second tallest building on Earth actually sinking along with the city beneath it? And if it is, what happens next? To understand this, we have to look at exactly what would happen if the ground underneath this tower ever truly gave way. Picture the worst-case version of this story. Shanghai Tower sits on a foundation embedded deep in delta soil that has spent the last century compacting under the weight of a megacity. If that foundation ever shifted unevenly, even slightly, the consequences wouldn't stay underground. A building swaying 632 meters in the air doesn't tilt gently. A lean of even a fraction of a degree at the base translates into meters of displacement at the top floors. Structural stress at the upper levels would spike. Elevator shafts, designed to run perfectly vertical, would bind and jam. The building's mechanical systems, water, power, fire suppression, all engineered around a perfectly plumb structure, would be thrown out of alignment, floor by floor. And here's the part that should genuinely concern you. Shanghai Tower sits inside Lujiazui, the single most concentrated financial district in China, surrounded by other super tall towers, all standing on the same compressing river mud. Here wouldn't be an isolated incident. It would be a test case for every other skyscraper built on the same sinking delta. There is one thing standing between this building and that kind of sway, a 1,000-ton steel weight suspended on cables between the 125th and 126th floors, swinging silently in the opposite direction of the wind. It's called a tuned mass damper, and it's the only thing keeping a 632-meter tower from feeling every gust off the South China Sea. It was built to fight wind. Nobody designed it to fight the ground. This isn't a hypothetical engineers dreamed up for fun. It's the exact scenario that has already happened in slow motion across entire neighborhoods of Shanghai, decades before this tower ever broke ground. To understand why, we need to go back to 1921, the year Shanghai's sinking was first recorded. The city was exploding, textile factories were multiplying, hundreds of thousands of workers were flooding in every year, and every single one of them needed water. The fastest way to get it was to drill straight down into the aquifers beneath the city and pump it out non-stop with zero understanding of what that would eventually cost. By the 1960s, Shanghai was extracting 200 million tons of groundwater every single year, and the ground responded exactly the way an emptied sponge responds to pressure. It collapsed in on itself. At the absolute peak of the crisis, parts of the city were sinking 10.5 centimeters in a single year, not over a decade. In 12 months, streets cracked open overnight. Building foundations shifted while families slept inside them. By 1965, the city center had already lost 2.63 meters of elevation. And here's the part almost nobody expects. Scientists studying Shanghai's subsidence later calculated that roughly 94% of the modern sinking is human-caused. Not bad soil, not bad luck. Groundwater extraction first. the weight of skyscrapers and subway tunnels second. Shanghai Tower didn't create this crisis. It was built directly into the middle of one that had already been unfolding for nearly 90 years. So what did scientists and engineers actually do about it? Faced with a city that was disappearing into itself, Shanghai's officials made a decision most cities never attempt. They didn't just stop pulling water out of the ground, they started pumping it back in. Engineers developed a program known as Winter Recharge, Summer Withdraw, injecting millions of tons of treated water back into the deep aquifers every year, rebuilding the underground pressure that decades of extraction had destroyed. It worked. The catastrophic sinking slowed dramatically, but slowing it down wasn't the same as solving it, because the city kept growing, and growth brought a second wave of risk. Through the 1980s and beyond, hundreds of new skyscrapers rose across Pudong, including the site where Shanghai Tower would eventually stand. So, engineers added a second layer of defense, specifically for the soil beneath the tallest, heaviest buildings. For Shanghai Tower itself, that meant driving foundation piles roughly 86 meters into the earth, deep enough to bury a 25-story building standing on its end, punching straight through the soft, compressible clay responsible for the city's worst historical sinking, anchoring instead into far more stable ground well below it. Instead of relying on a single massive anchor, the tower's weight was spread across a wide network of piles, distributing the load, so no single point of contact would ever bear enough pressure to trigger the kind of localized collapse that cracked the streets nearby in 2012. All of it, the piles, went into a tower that took nearly 7 years to build and cost roughly $2.4 billion, almost double the price tag of the Burj Khalifa, the only building on Earth still taller than this one. Strict new laws followed too. Zoning restrictions capping subsidence at 6 millimeters a year, limits on building density, and a citywide ban on new deep well drilling. On paper, the crisis was contained. So, is Shanghai Tower actually sinking? Officially, no. The tower's foundation was engineered specifically to bypass the soil layers responsible for Shanghai's historical subsidence. The cracks that alarmed residents near the site in 2012 were tied to groundwater-driven subsidence in the surrounding district, not a failure inside the tower's own structure. By every official measurement, Shanghai Tower stands exactly where engineers designed it to stand. But here's what officials won't put on a press release. Shanghai itself has never stopped sinking. Even after a century of intervention, even after billions spent on aquifer recharge and strict drilling bans, the city's core is still dropping 5 to 6 millimeters every single year. And Shanghai Tower isn't floating above that. It's standing on the exact same ground, in the exact same district, subject to the exact same slow-motion subsidence as every street and subway tunnel around it. So, unofficially, the tower is sinking, just not on its own. It's sinking the same way the rest of Shanghai is sinking, millimeter by millimeter, year after year, as part of a city that hasn't actually solved its 100-year-old problem, only slowed it down. The foundation may be perfect, but a perfect foundation built into a sinking city is still, by definition, sinking with it. Shanghai Tower is proof that human engineering can outsmart 100 years of failing ground, but the city around it is still losing centimeters every year to a crisis it has never fully ended, only delayed. And while Shanghai fights to hold its ground, another western coastal megacity is losing the exact same fight, far faster, and the stakes there are infinitely higher. We are talking about Miami, where right now, 35 super mega tall skyscrapers and a billionaire coastline are rapidly surrendering to the ocean. To see the terrifying sinking reality and the trillion-dollar catastrophe unfolding in Miami right now, click on the video on your screen immediately. If this video changed how you see the world's tallest skylines, please like, subscribe, and tell me in the comments. Would you still book that hotel room on the 120th floor knowing what is happening beneath it? I'll see you in the next one. Keep building big.